Good evening, everyone. Thank you for clicking on this video. It means that you actually care about my class and you want to do well and you want to... Good evening, everybody. Thank you for clicking on this video. I know it's going to be very helpful when solving this worksheet and solving the problems in the worksheet. I know it looks tricky and it looks like it's a lot, but really, I promise you guys, if you understand this map over here, your life will be so much easier. So we're going to do 3 questions together, the ones that I highlighted. Okay, so 1, 2, and 4. We'll do those together, and then hopefully after doing a few problems together, you should be okay to do the rest on your own. Of course, if you have any questions, you can email me, message in the group chat, comment on the video, whatever you want to do, I'll answer your questions. Okay, so first things first, I started off with my map. Okay, so I drew the map. There's a slide like this in the PowerPoint with the map. We're doing number 1, but number 1 doesn't give us a reaction. Okay, so I just left it blank. Number 2 gives us a reaction, so I wrote it here. And number 4 gives us a reaction, so I wrote it here. Okay, so we're doing these 3 together. Okay, we'll start with number 1. So it says, how many moles? That's huge, huge. I'm going to highlight that. How many moles? That's important to us. Of ammonia, and it, by the way, it gives us the formula for ammonia, so you're welcome. How many moles of ammonia? Off the bat, everyone should know this is what we're looking for. Okay, so how many moles of ammonia are produced when 0.60 moles of nitrogen react with hydrogen? Okay, so it gives us 0.60 moles of nitrogen. That is what our given is, okay, our given. So we are given moles of nitrogen, and we are looking for moles of ammonia. Okay, you'll see why I put a 2 here in a second. It does not give us a chemical reaction, therefore we have to write it ourselves, but it basically kind of tells us what to do. Okay, how many moles of ammonia are produced? Ammonia are produced. So off the bat, I already know I'm going to have ammonia as my product. So I'll draw an arrow, NH3. Okay, that's one of my products. Okay, and then it says are produced when 0.60 moles of nitrogen reacts with hydrogen. Nitrogen reacts with hydrogen. Okay, remember, Brinkelhoff elements are diatomics. These guys, they can't stand alone. They come in pairs. Okay, so nitrogen and hydrogen are all Brinkelhoff. So I will put a 2 there in my chemical equation. If I didn't put that 2, I would actually get the whole thing wrong, because then you wouldn't be able to balance it correctly. Okay, so be careful with that. Okay, now here is the skeleton equation, not balanced. So I have nitrogen and hydrogen producing ammonia. It doesn't mention anything else in this problem, nothing else. So I know this is correct. Now I have to balance. 2 nitrogens are here, 1 is here. I will put a 2 in front to make my nitrogens balance. 2 times the 3 hydrogens on this side is 6. So I will have a 3 here to make this hydrogen become 6 also. And I already have the 2 nitrogens here. So now my reaction is balanced. Okay, so I wrote out my chemical reaction. I cannot solve any of these problems without a chemical reaction. Okay. I have my given. It's in the problem right here, highlighted in green, 0.60 moles. So I will write that here. 0.60 moles of nitrogen, okay, of nitrogen, but not N, and what? And 2, that's very, very important, times the fraction, okay? Our given moles of nitrogen, we're looking for moles of ammonia, okay? So I have my moles of substance 1, and I am looking for moles of substance 2. Remember, whatever substance you're given in the problem will always be substance 1. Okay? So given will always be substance 1. Looking for will always be substance 2. Always, 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 no matter what. Okay? So if I look at my map, I am given moles of S1. Moles. Sorry, let me use a different color. I am looking for, so oh my god, let me repeat. I am given moles of S1 and I am looking for moles of S2. Okay, I am going from step 2 to step 3. That is one jump, one step. I only use one conversion factor for this problem. Okay, the numbers that I put on top are steps. So step 1, step 2, step 3, step 4. And to jump in between to each step, you have certain conversion factors you need to follow. So be mindful of that. Okay, so now that I know what I need, I will solve. To go from moles of S1 to moles of S2 is one jump. I need the mole ratio. I can just put everything in one fraction. So what am I looking for? Moles of S2, I will put that on top. Moles of substance 2, which is NH3. Okay, because I'm looking for NH3. Remember, our looking for will always be substance 2, which again in this problem is NH3. I'm canceling out what I'm given, which is the moles of N2. That will go to the bottom. When I have a mole over a mole, we call this mole ratio, right? We need, again, to get from step 2 to step 3, we need the mole ratio. I can get that from the balanced chemical reaction. Okay, so for moles of NH3, how many moles do you see? What is that coefficient? 2. Okay, so I will put a 2 over here. How many moles of N2? There is no coefficient in front, so we put a 1. There's no coefficient, it's just 1. Okay, to get my answer, I multiply these two numbers together because the 2 is on top and not the bottom. I get 1.2 moles of NH3 as my final answer. Okay, and I need units. Sig figs, don't worry about it, but I need units. Final answer. Okay, number 2. Number 2, it gives us the chemical reaction, so we don't have to worry about that. Let's just focus on what it's asking. Remember, all we care about is what we're looking for and what we're given. So it says, if 125 grams of KClO3 decomposes completely, how many moles of oxygen is produced? Okay, again, what's the number? 125 grams of KClO3. This is my given. Everyone should know that this is my given. It's the only thing in the problem. I am given grams of KClO3. And I am looking for, okay, what is the question asking? How many moles of oxygen? I am looking for moles of oxygen, not plain O. What does it say here? O2, O2. Careful. Okay, so again, if I have a substance that I'm given, it will always be substance number 1. My given is KClO3. So I have grams of substance 1, and I'm looking for moles of substance 2. My looking for is going to be substance 2. Okay, substance 1 and substance 2. And there's my setup. Okay, so let's go back to my map over here. Let me erase all of this. My map. Okay, this is what I'm looking at right here. Sorry. This. Okay. So, I'm at grams of substance 1, and I'm looking for moles of substance 2. So, I'm going to erase this for a second. Actually, that's all we need. Now, step 1, to get all the way to the red highlight over here that I did, 2 steps, 2 fractions, 2 conversion factors. Okay, I start with my given is 125 grams of KClO3. That's given to me in the problem. I always take this given and I times a fraction. Okay, again, I am starting here. What is the first step from step 1 to step 2? What am I looking for? Moles of S1. Okay, moles of substance 1 is substance 1 what I start with. So I'm looking for moles of KClO3. And then on the bottom, I'm canceling out grams, so I put that there. Okay. Moles of KClO3 versus grams of KClO3. Moles over grams, grams over mole. That is molar mass. Molar mass. I need the molar mass of this compound. KClO3. Okay. If I remember, let me pull up your table. K is 39.10, I believe. Hopefully this is the right number. If not, use the right number, same steps. Chlorine is 35.45. Oxygen is 16, but there's 3 of them. So 16 times 3 gives me 48. Okay, I'm going to add up all of these numbers together in my calculator. 39.10 plus 35.45 plus 48. This gives me 122.55 grams per mole, because this is molar mass. Okay, grams per mole, obviously again, because this is molar mass. So 122.5 grams, 122.5 grams. That will go on the bottom by 5, grams per 1 mole. There's my first setup. Okay, I'm going to erase all of this so I can make space. No, I don't know. Okay, good. So these units cancel out, and I just found moles of my first substance. So I just completed this step right here. Now I need to go to my next step. I want moles of substance 2. So I will go to my next step right here by multiplying by another fraction. And I will put moles of substance 2, what I'm looking for, on top. Substance 2 is given in the problem. It's asking me for moles of oxygen. So moles of substance 2, moles of oxygen. And I got to cancel out this unit that I had. I cancel out these, and now I got to cancel out this guy. So that will go to the bottom. Okay, when I have 2 moles on top of each other, so mole over mole, right? In order for me to jump from substance 1 to substance 2, I must use a mole ratio. This is a mole ratio. This will take me from one substance to another substance. Okay, that's what mole ratio does. So I can get these numbers again from the balanced chemical reaction. Moles of O2, right here. How many moles of O2? What does the coefficient say? It's all you're writing. 3. Okay, and then moles of KClO3, moles of KClO3, 2. I'm just writing the coefficient. Okay, very, very easy. Equal. Now my units cancel out. I'm looking for moles of O2. Is that true? Yes. Look what the problem says. How many moles of oxygen? So that is what I'm looking for. So I will plug this into the calculator and I will get my answer. So all I have to do is, I don't know what I'm doing. Hold on, sorry. I will plug this into the calculator. 125 times 3 divided by 122.55 times 2. Okay. And you should have gotten 1.5299 moles of O2. Okay, and I'm pretty sure that this is correct. Let me double check my math. Hold on. Yes, that's correct. Okay, so again, don't worry about the sig figs, but if I were to round to sig figs, I usually like just 2 decimal places. It looks cleaner for me, but again, don't worry about it. The sig figs in the answer key, so like over here. Oh, and I forgot to tell you the most important part. Hold on. Okay, so let me erase all of this mess over here because it's too much mess. Okay, erasing it. We just said over here that 1.2 moles of NH3 was our answer for number 1. Look for 1.2 moles over here. Do you see 1.2 moles anywhere in the answer key? I do, right there. What number is this? 16. So I will put 16 on the line. Okay? Question 2. Okay, then we just solved and we found this next problem answer. We got this. Okay, but let me see. What's the number that we see here? 1.5. Do you see 1.529, 1.53? Which one do you see? Okay, I see over here 1.53. If I were to round it, like I said I like to do, I would get 1.53 moles of O2. So there's the answer for number 2. Right? There's number 2? Yes. See? So what is that number right there? 2. So then I will put that number on the line. And then you just cross out the ones that you do so you don't get mixed up. Okay, so far we've done 1 and 2. Okay, last and not least, we're going to do number 4 because it's a little bit long, and I feel like you guys might have questions, so we'll do it together. Okay, number 4. I'm going to erase this. I'm going to also move this box down here, and I'm going to erase this. Okay, so for this question, gives us a reaction already. That's perfect. Okay, gives us our reaction. So I already wrote it down here on this paper for number 4. Remember, I was skipping number 3. It's right there. How many grams of C2H2? Off the bat. How many grams of C2H2? Looking for. If it's a looking for, it's substance number 2. Okay? Are produced by adding water to 5 grams of CaCO2. This adding water to blood, that's just filler. I don't care about that. All I want is the direct verbiage that tells me what I'm looking for and the direct verbiage of telling me what I'm given. Okay, here is my given. Here is my looking for. Given is always substance 1. Okay, I am given 5 grams of CaC2. So I will put that here. 5.00 grams of CaC2 times a fraction, always, all the time, no matter what. Okay, so my given is grams of CaCO2. And I'm looking for grams of C2H2. Okay, I'm going from grams to grams. According to my nice map over here, grams to grams. Let me choose a different color. Grams to grams. This is the longest step. From step 1 to step 2, that's 1 fraction. Step 2 to step 3, step 3 to step 4. So 3 fractions I should have, and these are the conversion factors I will be using. Okay, so let's start off. We are here. Right there, we're here. Let's go to my first step. Moles of S1. So again, my starting point is CaCO2. That will be my S1. So I'm looking for moles of CaCO2. CaC2, sorry. Okay, and I'm going to cancel out the gram, so I put that at the bottom. Moles per gram of the same substance is molar mass. Okay, so CaC2. Calcium, I believe, is 40 point something. But let me just double check that. 40.08. Okay, and carbon is 12, but 12 times 2 is 24. So then I will do those 2 numbers added together, and I should get 62.08 grams per 1 mole. Okay? 62.08 grams per mole because it's molar mass, right? We went from here to here. I used molar mass of substance 1 in my fraction. Okay? Times my next fraction. These guys just canceled out. I'm left with this. So right now, I'm at moles of S1. I don't want that. I need grams of S2. So let's keep moving. Now I'll go from here to here. So from step 2 to step 3. Using the mole ratio. Okay, now I'm looking for moles of S2. So I will put moles of S2 on top. Okay, moles of S2. But I'm not writing S2 here. No, I'm writing the actual substance. What is S2? S2 is my looking for. Okay, what am I looking for here? Right here it says, how many grams of C2H2, acetylene. So I'm looking for, I'm not going to put moles of S2, I'm going to put moles of C2H2. Okay, and I'm canceling out what I have over here. This brings down to the bottom. Okay, I have moles of CaC2. Now these 2 units cancel out. Remember, again, when I have moles of one substance over moles of another substance, 2 different things, it's called mole ratio, and I use mole ratio to convert from one substance to another substance. I get the numbers by looking at my reaction. So what are the moles of CaC2? CaC2. What are the moles? There is no coefficient, so it's just a 1. I'll put 1 there. What is the moles of C2H2? C2H2. Just 1 again. Perfect. Okay, times the fraction. And that will happen. Don't worry about it. I just found moles of my substance 2. We just did this step, last and final step, grams of S2. So now I'm looking for grams. Sorry, wrong color. Looking for grams of C2H2. Okay, and this guy goes at the bottom because I'm trying to cancel it out. So moles of C2H2. These cancel out. When I have grams per mole of the same substance, that's molar mass. So what is the molar mass of C2H2? Carbon is 12 times 2. Hydrogen is 2. Gives me 24 grams per mole. Sorry. 26 grams per mole, because this one is 24 plus 2. Gives me 26. Okay, so 26 grams per the singular mole. Okay, beautiful. I'm going to erase this to make space. Now all I have to do is just do the math. Multiply the top, this is the top, divided by the bottom. Okay, this is the bottom, but you know, the ones don't matter. If you have my calculator, you plug it in by fraction, you plug it in by fraction. Perfect. So I have 5 times 26, give me 130. Divide that by 62.08, and I get 2.094 grams of C2H2. Okay, so let's look at my answer key, my answer sheet. I'm going to erase all this mess again because it's too much stuff. Okay, I'm looking for this as my final answer. Well, actually, I'm going to circle it for now. We'll see what we get the closest to in the key. So look for 2.09, 2.1, somewhere around there. 2.03. I got. Hold on. No one move a singular muscle. Okay, 5 grams of CaC2, grams of CaC2, moles of CaC2. The molar mass of CaC2 is hold on guys, am I dumb or something? Hold on. I don't have my periodic table. Actually, yes, I do. Yeah, 1.08. 0.08 plus 12 plus 12. 64 point. Oh, I see what I did there. I can't do math. Okay, so hold on, guys. Everything here is correct. We did every single step correctly. I am dumb and oh shoot. I can't add, apparently. When I add this together, I put 62.08. That's wrong. It's not 62.08. It's 64.08. I know you were yelling at me through the screen and telling me it's wrong. I know. I'm sorry. So again, the molar mass was just wrong by 2 digits. So over here, got to fix that. Okay, it wasn't 62. It was 64 because Miss A is silly and she misadded these two numbers together. Okay, so now I'm going to recalculate that with that fixed digit. See how simple, see how easy these mistakes can be made and then mess you up? Okay, great. So now I have 2.0, not 94, 28 grams of C2H2. Okay, that makes more sense because look over here. I have 2.03. If I rounded this to 3, see how this has 3 sig figs? If I rounded this to 3 sig figs, I would get the same thing. Third sig fig, rounded, 2.03 grams. So that would be my final answer. Okay, again. So for number 4, right, we're on number 4. Oh my God, it scared me. Okay, and we're on number 4. The answer is this. Right here, I found it in the key. What number is this? 13. So I will go over here and write 13 on the line. Okay, then you get a final number here. Let's say the number was 3. I'm making that up. I'm literally making that up. I don't know what it is. Then, how do I get the total? 16 plus 2 plus 3 plus 13. 34. Oh my God. 34 goes there. Okay? Then I would just put that there, and then I would add all the rows, and I would do the same thing for every row, and then I would do the same thing for all the columns. Okay? So that's what I would do. Again, I just made this up. I don't know if that's the right answer or not. There you go. So that's questions 1, 2, and 4 we did together. The work is shown. It's nice and organized. Do you see how I wrote the chemical reaction for every problem? I wrote the chemical reaction for every problem. I showed my dimensional analysis. I squared and highlighted all of my answers. Very simple, okay? Do the same exact thing. Please keep it organized. If you have any questions, let me know. Thank you for watching, and I hope you guys have a good night.